Okay, so hello and welcome to today's webinar. Thank you very much for joining us. My name is Stuart Scott and I'm the AWS and Security Content Lead here at Cloud Academy. And in today's session, we're going to be learning how to accelerate your big data application performance and lower costs by using Amazon EC2 Spot instances with Amazon EMR. Now, cost optimization is an area where all organizations strive to implement best practices. And if you don't look into the many available options to you when architecting your workloads, you can soon become overwhelmed with unexpected costs. So in this webinar, we hope to introduce you to a great option to help you reduce your operational spend when using EMR and EMR clusters. Now, on the panel with me here today, we are very lucky to have Chad Schmutzer from AWS, who is a principal developer advocate for EC2 Spot instances. So, hello, Chad. Thank you very much for joining me on this call today. How are you, and where are you calling in from?
Hey, Stu. Thanks so much for having me. I'm great. It's a pleasure to be here. I'm based in Los Angeles, California. Specifically, I'm in Pasadena. So
Nice.
It's wonderful to be here. Thank you.
No, thank you for joining. So I'm really looking forward to hearing the content that you're going to be running through with us today and some of the different methods to adopt to help us all implement better cost savings across our EMR clusters when working with big data and data analytics. Now, before I hand over to you, Chad, to give us the agenda for today, I just want to let everyone know that this webinar is being recorded, and so you'll all receive a link to it as soon as it's being published. And also, if you do have any questions throughout, please use the chat window and we'll get to as many of them as possible during the Q&A at the end. So just if you think of anything throughout the webinar, please just drop us a message. Okay then, Chad, let's get straight into it with the agenda.
All right, thank you, Stu. Okay, so we've got a action-packed agenda here today. I've got it here on the screen, but what we'll do is we'll start with a baseline leveling of what Amazon EC2 Spot instances are and how they can help you in your workloads. Then we'll dive into an overview of Amazon EMR. Then we'll talk about options for different purchasing options for using different node types within Amazon EMR. And then we'll dive into EMR instance fleets to sort of help us put this whole thing together, talking about how we can combine Spot instances with different purchase options with instance fleets within EMR. And then we'll take some time and go through a demo. We'll run a example Spark app on Spot instances with EMR. So that's our agenda. As Stu said, please don't be shy. Please put your questions in the chat room. We'll do our best to get to them. We want to make sure this is as interactive as possible and we all just have a good time learning together. Okay, so real quick, just about me, if my contact information is here if you ever want to reach out to me directly or hit me up on Twitter.
Great photo.
Thank you. Yes, what being in quarantine for a few months here, I haven't had a chance to shave. So, yeah, this is who I am. I'm from California, Pasadena. I've been doing Spot for quite a while. I've been with AWS for a little over 7 years. Majority of that time, I was a solutions architect. Really got into the love of cost optimization at scale and got into Spot instances, and I've moved into this role where I get to help customers save money, and it's a really fun role because I'm not helping them save a little bit of money, I'm helping them save quite a bit of money, and it really feels good. Customers are happy, I'm happy, we have a good time, and it's all about learning how things work and following best practices. So there I am, there's my contact information if you ever want to reach out to me. Okay, so Spot instances, what are they and how can they benefit you? If you've used AWS in the past or have not, either way, you probably have heard about we have different purchasing options. The most common one that you think of when you think of the cloud is the on-demand purchasing option, right? No long-term commitments, pay by the second, great for spiky workloads or as you're defining your needs. You simply spin things up, when you're done, shut them off, utility-based pricing. It's really what the cloud is all about. That's the default purchase option, if you will. As you sort of define what you need over time, another great option to lock in savings is to look at something called savings plans. There's a lot of flexibility with savings plans. Helps you get great discounts over a 1 year or a 3 year period of time, really flexible with your compute consumption. But savings plans are for workloads that are running all the time. And it's really where you're at, you've got some capacity you need to be running and you want to lock in savings with that. Great for, just use savings plans. It makes the most sense. So on the right, though, what we'll talk about today are spot instances, which are your ability to tap into all of the spare capacity we have from all this capacity that we've spun up for the on-demand part, right? So we need to be able to let customers spin up to large amounts of scale at any point in time. So that means we have a lot of spare capacity sitting around. Rather than letting that sit idle, we make it available to you as what we call spot instances. They're great for fault-tolerant, flexible, stateless workloads. You can find savings up to 90% off of the on-demand prices. So it's really important to understand how spot capacity works and capacity in general with AWS. Each instance type, each instance size, each availability zone in every single region is a separate pool of physical capacity. So that means when you think about asking for spot instances, you're saying, hey, can I get access to that spare capacity? We're going to think about, well, that spare capacity is going to be fluctuating. Sometimes we're going to have more of it in one pool and less of it in others, and then the next day it's going to change because it's a fluid environment where customers are spinning things up, shutting things down. So when you ask for access to spare capacity, you want to say, well, how many different places can I look for it? And so what we like to say is be flexible when you think about consuming our spare capacity. Think about the fact that a C4 large in US East 1A is a completely separate pool of capacity from US East 1B, and likewise for an extra large. So there's all kinds of different places you want to look into for getting access to spare capacities. You think cross families, generations, sizes, etc.
Just a quick question, Chad. I
Yep.
know you might cover this later in the presentation, but is there any restriction on which EC2 capacity pool can be used with EMR?
Slightly. So EMR, right, because it's a managed service, it does qualify different instance types to be used with EMR. And so you'll see when you
Okay.
go into the EMR console, it will filter on which instance types are available to be used. It's a wide range, but it is slightly restricted based on what EMR has qualified for instances to use within the EMR service.
I see. Cool. Thank you.
Yep. Yeah. Great question. Thanks, Stu. So again, spot instances are strictly the same capacity that we have for on-demand. It's the same. You're just paying for it in a different way, right? So it's all the same stuff. You're just paying for an EC2 instance with spot pricing versus on-demand pricing. Spot pricing does change though. It can change based on long-term trends in supply and demand. However, it's typically very smooth, infrequent changes. We only change it if we need to over longer periods of time. Spot is an interruptible service, right? When we need that spare capacity back, we will interrupt you with a 2-minute interruption notice, and we take the instance back. So that's how it works. It's an interruptible service. It's something that you want to understand from the beginning and make sure that, again, when you're architecting for using Spot, that you take into account interruptions will occur, and that feeds into why you need to be flexible, because if at some point one of those pools that we talked about on the previous screen becomes constrained, we would potentially take those instances back from you. But then there's plenty of other places to get spot capacity, right? So then you just say, well, if I can't get it in this particular AZ, I'll try this AZ, or I'll try a different type or a size. And we have all the tools that will do that for you automatically, including EMR, which does that natively for you. So again, this is what Spot is. This is how it works, and hopefully you have a good understanding of what it is now. So again, Spot is an interruptible service. The idea here is that you want to embrace that fact. You want to understand the potential cost of interruptions to your particular workflow, and then take into account Spot best practices to effectively use Spot, right? So again, the work that you're doing to make your applications fault tolerant for the cloud in general are also benefiting your ability to use Spot. So if you think about a workload behind a load balancer, you probably are already in a position where you can add and subtract capacity to a particular workload. Spot is no different than that. If a Spot instance gets interrupted, you simply replace it with another Spot instance from a different pool of capacity, and you continue on your way. But it is important to understand Spot is optimized for stateless, fault-tolerant, or flexible workloads. It's not for your databases, right? It's not for stateful databases running on an instance, because that instance will be interrupted at some point, and you don't want to lose data by putting stateful data on a spot instance.
So just a quick question. After those 2 minutes, is all your data removed, or is it down to the customer to remove any data that might be on that instance?
Yeah. So since storage is decoupled from compute by default with EBS volumes, you have the option to say persist my EBS volume outside of the instance, so the instance can get interrupted, but
Sure.
but the EBS volume can persist. Typically, customers will have, well, they will monitor for the 2-minute interruption and do some sort of checkpointing or copy data to S3 or detach the volume. There's all kinds of different things. Containerized workloads will drain containers off of the instance and move them somewhere else. So there's all kinds of different methods, but it's up to you. If you
Just something to be aware of.
yep, no, yep,
Cool.
absolutely, and it's an important thing to understand, and this is something that EMR handles for you as a part of the managed service. Okay, so let's get into Amazon EMR. So Amazon EMR is an enterprise-grade managed solution for Hadoop and Spark, and other workloads as well. So typically, customers will use it because it's a fully managed service. It's designed to help you scale your compute and your storage independently. It's capable of storing, any vast amounts of data, whatever you need to process, whether it's, gigabytes, petabytes, terabytes, exabytes, you name it. EMR can help you process it. It's very scalable. You can have a 1-node EMR cluster. You can have hundreds or thousands of nodes. It's completely up to you. And it has, fully managed scaling built into it. So it can actually scale itself up and down based on the amount of work that you're throwing at it.
And am I right in thinking that it also supports HBase and Presto frameworks as well?
Absolutely. It handles a whole suite of application environments. As Presto, HBase are some of them, as you pointed out, Hive, and many others, in fact. Hopefully I can show you them in the console when we launch. But yeah, good point. It's
Oh,
not
yeah,
just
great.
Hadoop and
Yeah.
Spark. Yep. So again, when you decouple your storage from your cluster, EMR allows you to actually treat S3 as your primary file system instead of using HDFS, which is local file system on the local instances. So when you put the data into S3, you automatically achieve your 9s of durability. This allows you to safely implement, your data on S3 and allow safe decoupling of the compute and the storage, which feeds into the ability to use spot instances. EMR monitors your cluster, right? So it's going to replace failed nodes or interrupted nodes. It automatically will restart services if there is an interruption. You can see your metrics of the monitoring of your clusters in CloudWatch. You have a built-in console to view your job. You can also do everything through the CLI, of course. And for those customers that do need an environment that needs HDFS instead of EMRFS, which is the S3 ability to use instead of HDFS. For those that do use HDFS, it will manage your HDFS for you automatically for data persistence as well. So, putting all this together, what are the benefits here? So EMR by itself is already providing the automation, right? It's launching everything, it's provisioning the compute, it's managing, bootstrapping the environment for you, managing your jobs. It helps you to decouple your compute and your storage natively. It's tightly integrated with many other AWS services. Something I haven't talked about yet, but the fact that you can, connect EMR with a multitude of other AWS services, Glue, Batch, or others, right, where you can move data from one environment to the other, process data, pass it to something else. SageMaker, lots of different ways to couple your data processing, and it's also current, right? So the EMR team is doing their best to stay current with latest versions of the software that you can run on top of your EMR clusters, and so it helps you stay current automatically by simply using a newer version of the releases. And finally, when we start to throw in the idea of Spot, it helps us to think elastic, right? So because Spot is built-in discounting automatically, and because it's unlocking access to vast amounts of spare capacity, it's helping you scale up your cluster as much as you need to, and it helps you reduce the cost at the same time. So these two go together very nicely, and the fact that you can scale and save at the same time is one of those unique things that comes along with the integration between EMR and EC2 Spot instances. All right, so an EMR cluster is comprised of three different types of nodes. We have the master node, which is taking care of basically running the cluster, right? It tracks the status of the task, it monitors the health. It's a really important and critical part of the cluster. The core nodes are nodes that run tasks and store data. They add HDFS to the cluster if we need it. And then the task nodes are basically independent additions of compute and memory as needed. They don't contribute to HDFS, which makes them a very great method for adding in Spot instances, right? Because we're simply able to add compute capacity, take away compute capacity as we need it without affecting the overall cluster. So if you need more compute, simply add more task nodes. When you don't need them, take them away, and that's a great option for using Spot. So we do want to think about what is the right scenario, what are the right purchasing options for different types of instances within the cluster. So we want to think about long-running clusters. We want to be a little bit more tilted towards on-demand because we don't want to have potential interruptions because our cluster is long-running. We probably want to keep the master, the core nodes on demand or a mix, and then the task nodes can either be pure Spot or a combination of the two. As we move down the chain, we can get more aggressive going towards Spot. So as we move more towards transient workloads that are cost-driven or that are completely transient, where you're spinning up a cluster and tearing it down when the job is finished or the jobs are finished, then we can get more aggressive about using Spot throughout the cluster. A great middle ground is typically think about using on-demand for the master node because, again, an interruption would, at the master level node, would bring down the entire cluster. And then you can get more aggressive with a combination of Spot and on-demand or pure on-demand for core nodes, and then use pure Spot for task nodes. And there's a lot more to learn and read about this here at this link below. But again, think about your particular requirements. Think about where you want to land in terms of cost savings, but as well as any time SLAs you may have.
Yeah, it's interesting to see how you can use the Spot instances in the different use cases there across the different node types. Definitely something to think about there for optimizing costs for sure.
Yeah, and it's fun to see customers implementing this, right? I've got customers in every single category here. Talk to all of them, and they're all doing unique, neat things, and they're making it exactly what they need, right? It's this beautiful blend of ability to get a job done and saving money at the same time, and I love the flexibility here.
Do you come across many customers that aren't using Spot at all, and it kind of surprises you that, or surprises them, the amount that they can be saving?
I do. Because of sort of the things that we talked about earlier, they may have concerns about interruptions, or they may not understand how the pricing works. It's just a matter of sort of, digging in a little bit, or maybe running a POC, or doing some experiments and getting
Sure.
these configs in place, and then kind of like then the light bulb goes off, and I talk to them 6 months later, and I'm like, wow, I've saved 30% on my bill. Like, that's a pretty good amount of money to save, right?
Yeah, definitely. Yeah.
And sometimes it's a lot more than that. It just purely depends on what mix they put in here.
Yeah, it's interesting. Thank you.
Yeah, no, of course. So again, combination of meeting your SLAs at predictable costs, or exceeding your SLA at a lower cost. It's just a matter of figuring out what this right blend is for you, and running with it. Following best practices is critical, of course, and we just want to think about where do we land here in terms of what your needs are, and then you can go. One thing that really made the light bulb go off for me a few years ago was like the fact that I can run a single job with one instance, and it could take 10 hours. But if I parallelize that job and I run 10 instances, I can get that same job done in an hour. And this is sort of, the beauty of like the cloud, but also the scale and the cost effectiveness of using Spot for this particular thing.
Yeah, the flexibility is great when you look at scenarios like this.
Yep, it's a lot of fun. And like tinkering, like I tinker with this and try different configurations and kind of find that sweet spot, and it feels really good once you find it.
Yeah.
So let's kind of put this all together. Let's think about how we can implement Spot within our EMR environments, and we can do this with following best practices with what are called EMR instance fleets. EMR instance fleets are a method for specifying a target capacity with a mix of instance types. So we talked about earlier, being flexible with Spot is critical. So EMR allows you to say, I can use up to 5 different instance types for my master node and my core nodes, and up to 15 different types for my task nodes. So why is this important? Well, if we don't have enough spare capacity for you with the first instance type, there are 14 others that it can look at to find that spare capacity for you. And so this is sort of the fundamental best practice for thinking about how to find spare capacity through EMR. And they have a configuration called allocation strategies, which I'll touch on here in a second. EMR will attempt to fulfill capacity from the most suitable pools. So when you put in those 5 or 15 different instance types, EMR will automatically fulfill the capacity from the most available pools of spare capacity. So we have a ton of spare capacity, but the idea would be like, let's put you into the one where we have the most available to reduce likelihood of interruption. So it's doing all of that for you. Furthermore, it uses something called managed scaling, which we'll enable here in our demo to further fine-tune cost and performance. So not only are we going to scale and save with Spot, we're also going to have managed scaling shut things down when we don't need it running, right? So it's not just a matter of using less expensive instances, but also shutting them off when we don't need them. That's a critical thing that a lot of customers also will miss, the fact that shutting things off at night, if you're not using them, simply saves a ton of money just by itself. And finally, EMR will automatically replace interrupted Spot instances. Again, putting in as many instance types as possible is critical, and EMR can go off and replace instances that are interrupted to allow the job to continue. Spark itself is inherently resilient to interruptions. It's kind of why we're keying in on this particular pattern here, but EMR has also made some contributions to Spark to make it more resilient, in particular to interruptions. So it's a really great workload and use case here.
So you can see that EMR is really integrated well with Spot, with the management features that it offers, with kind of replenishing failed instances, etc., and the different mix of instance types. It's I didn't realize it was so well integrated with the Spot fleet.
Yes, it's something that is really fun with Spot in general, is getting to work with other AWS services to integrate it in. So our whole goal is to save customers money and to help them spend the least amount they need to. And so as we work with other services to help build in best practices natively into the service, it really just the customer can just go and use it is the ultimate goal here, and
Yeah, it
not
just
think
makes it
about
very
things too
easy.
much. Yeah, exactly. So I did say EMR has the concept of allocation strategy. So what is an allocation strategy? Basically, it's a feature that is available in EMR as of version 5.12.1 and later. But what it does is it effectively optimizes the allocation of each instance fleet and lets you use the target strategy for each cluster node. It has two different options here. So when you use on-demand instances, the allocation strategy configuration will automatically use the lowest price strategy for the on-demand instances. So if you give it a list of 5 different instance types and you say, I want to use on-demand, it will pick the lowest price of those. If you, when you use Spot instances, it will automatically find the most optimal capacity for the Spot instances that it's using. Again, goal here is to reduce interruptions. You're never going to eliminate interruptions. They're not going to go away. That's how Spot works. But the goal here would be like, well, let's put us in the place where we're the most optimally configured from a available spare capacity perspective. So some key benefits for managed scaling. Managed scaling is a completely managed environment for automatically scaling your EMR clusters. So completely hands off, no configurations required. All you need to do is plug in min and max cost constraints to say, this is the minimum amount of capacity I need, and this is the maximum amount, and let it go from there. It's watching a ton of data points. It has faster reaction times. With some improvements that they've made, and it's really fun and great to watch it work. And again, managed scaling can also help decrease costs because it's automatically sizing your cluster resources based on the workload itself for performance and lowest cost. And so again, shutting things off and spinning things down is just as important as using Spot within your environment. And of course, managed scaling does work with instance fleets. So both allocation strategies and managed scaling are relatively new to EMR, which is why I'm focusing on them, and the fact that they're so critical with sort of optimizing for best practices. So we can see just an example of how managed scaling works effectively within a cluster. So we can sort of see this timeline here where we have batch jobs coming in, the cluster scales itself up, then it scales down when there's idle periods, another job comes in, repeat itself, and you can see the overlap of savings against what you would have had if you had just been running this cluster at full tilt. Even when the cluster was idle, you would have been paying for compute. In this case, you're shutting things off and you're rapidly scaling up and scaling down based on the amount of work that's in the job queue. Okay, so going back, let's put this all back together. Remember this slide here where we said, how do we think about this for our particular workloads? So if you're in an environment where you want to be aggressive with using Spot instances, but you still want to maintain availability at the master level and the core level because maybe you're using HDFS, well, you want to have a nice mix of on-demand, typically for the master and the core tier, and then you can use Spot for the task nodes. And this is something that managed scaling helps you configure within its configuration, and I'll show you that here in a moment. And then finally, if your cluster is completely transient and you want to be very aggressive with cost savings, maybe again you completely tear down the cluster when you're finished with your work. That's a very common pattern customers do as well. You can simply limit the amount of on-demand capacity that's used. Maybe you just use it for a single core instance, and the rest of it goes to task nodes. This is all something that managed scaling can help you configure. So it's just something to think about, and best practices are probably going to land between this one and this one, depending on what your overall workload requirements are. Okay, so let's jump into the demo. Stu, anything I missed or anything you wanted to point out?
No, I think you've covered it well. Covered Spot and how it integrates with EMR. So looking forward to seeing the demonstration.
Okay, awesome. So let's jump in here to my browser. Okay, if you haven't seen the EMR console before, it's here. We want to browse for services and just find EMR. It'll take you right to this console, and this is where we can get started. So here's the place. I have a few clusters running. Well, I have a few that I terminated. I have one that I pre-configured just because I've done live demos enough in my life to know that something always goes wrong somewhere. So I've got a backup cluster in case the live demo fails somehow. But let's hope it doesn't here. So let's make a new cluster, right? So let's start with the create cluster. Very first thing I'm going to do is I'm going to hit this go to advanced options. Now, don't worry, I still want to make things as easy as possible, but we want to go into advanced because we really want to think about optimizing for our Spot usage here. And this is where we're going to do it. All right, so Stu, here's your question that you pointed out earlier was, can't EMR do a lot more than just Hadoop and Spark? Well, absolutely, right? So we can.
It certainly can, yeah.
Yeah, we can see there's a whole slew of settings of applications we can actually configure here. And so, yeah, some of these, some of these are more more tuned for using something like Spot, and so we talk about things like Spark here. Others that are more long running, like an H-based cluster, probably is going to be more aggressive or towards on demand, because it's not something that is ephemeral. So, first thing we can do is we can simply select the applications that we want to use, and just for performance of launching the cluster, I'm just going to limit this just to Spark, because it helps reduce bootstrapping times for the demo. But ideally, we would have more things that we're running, or we could tune them to exactly what we need. Beyond this, there's not a ton else that we need to configure, right? So I'm just going to select the version of the release of my EMR. I'm going to go with 531, and I'm going to add Spark, and I'm going to leave everything else by default. After the last step completes, which means what happens when my cluster runs through bootstrapping, what should it do? I'm just going to ask it to just enter a wait state, meaning just wait for me to give it some work to do. Okay, so let's click next. All right, so here is where we can select instance fleets, first of all, in our cluster composition. So the first thing I'm going to do is select instance fleets. This is going to give me the most flexibility in terms of allowing me to tap into multiple instance types within my configuration for tapping into that spare capacity, which is what's going to give us access to spot instances and spot instances pricing. So the next thing we'll do is we will go into our networking section. You probably already have VPCs configured in your environment. I happen to have a couple. Here's one I like to use that I've laid out already. Important thing to know here, right? So Spot best practice, when you configure your VPC, use as many availability zones as you can. Reason for that is because, again, each availability zone coupled with instance type and size is going to give you access to spare compute capacity. The more AZs, availability zones, that you add, the more spare capacity it can find, right? Now, EMR is a single availability zone service. What that means is that it's ultimately going to launch everything into a single availability zone, but I can still tell it, please look across all availability zones and find the most optimal one according to how much spare capacity is available at launch, right? So I'm selecting, I have 6 availability zones in my VPC in Virginia here in my config. EMR is going to look across all of them based on my config and pick the one that's most optimal for launching that capacity. Does that make sense?
Yeah, definitely.
Okay, awesome. So critical best practice number 1, right? We've covered add every single availability zone to your VPC and use them. Okay, next is allocation strategy. Remember, this is the feature that is going to say, hey EMR, go pick the instance type that is the most optimal across the availability zones. So it's going to look at your instance types that we'll select here in a moment and find the most optimal for them. For on demand, it's going to be the lowest priced, and for Spot, it's going to be the most available, using what we call the capacity optimized allocation strategy. So best practice number 2 with EMR, make sure that you select apply allocation strategy. Okay,
Makes sense.
now hopefully straightforward so far. So moving on, now we have cluster nodes and instances. Here is where we can define the composition of our cluster, right? So we talked earlier about that balance between on-demand and spot, and then the flexibility. In this case,
So am I right in thinking you can't go into this level with regards to the master and core nodes unless you go into the advanced options? Is that right?
Correct, and it's really a function of instance fleets, because uniform instance groups allows you to pick a single instance type, and instance fleets is what allows you to pick the multiple instance types. But yes, you're right. So the advanced options are what lets you tap into sort of the more
customizable,
advanced, customized options. Correct.
Yeah, cool.
Yep, and of course you can do all of this from the CLI. Many customers just bypass the console completely and just use the CLI, and of course you could do all of this there as well. Okay, so I'm going to go ahead and use on demand for my master node, and of course I can select up to 5 instance types here. So let's do that, right? So let's pick. What I like to do is pick go back a couple of generations, this is really important, right? Customers love to gravitate to the most recent versions of our instance types, but we still have a ton of them left over from the previous generations, which means, hey, for Spot, there's a lot of spare capacity sitting in these previous generations. They work just great, right? They still perform as they always have, and it's really important to think about, can I use previous generations when I configure my environment? And then I'll also pick, how about an R3 extra large and an R4 extra large. So basically, because I've chosen on demand in allocation strategy, EMR is going to go off and find the most cost effective of these to use from the on-demand perspective. From a Spot perspective, in the core tier, when we select instance fleets, we automatically start to think about capacity in a unit instead of an instance, right? So what we think about here is how much, how many units is each instance going to provide to my overall cluster? And so basically these are like yarn executors, or vCores, I guess we can call them, within EMR. And so what we think about here is, well, how many units do we need to power our environment to start? So I'm going to actually ask for 4 Spot units, and I'm going to allow it to use sort of a similar pattern of instance types here. I'm going to actually go with probably the same list, just because it's easier for me to remember. M3 extra large, M4 extra large, M5, and then we'll tap into the R's as well. And the reason I'm sort of focusing on the M's and the R's is because traditionally, because Spark is an in-memory processor, environment, I'm leaning towards instance types that have a bit higher memory to CPU ratio, and understanding that EMR can effectively divide up my jobs across these, and bin pack essentially, right? So I'm able to say that each of these instance types is going to provide 4 units. And again, these are vCores as defined by EMR. And we can see that EMR is going to take care of understanding how much capacity each of these will provide. I can override the 4 and say, this particular one could give me a different amount if I really understand my job. But by default, if I was to say, pick an instance type that has 8 vCores, this could change to 8, understanding that if it gave me an 8 vCore instance, that I'm providing more additional overall units to my cluster. And then finally, we'll do the same thing with the task nodes. I'm also going to ask for 4. Actually, let's make this, let's do 4 for on-demand and 0 for Spot for right now for the core nodes. And we'll make this a pure on-demand master, on-demand core, and pure Spot for our particular cluster. Yep, for task. Thank you. And so let's go ahead and add in 5 different instance types here. Now you can actually add in more than 5 from the task side. However, you need to do that from the CLI. The console would get too long if I had all 15 here, but you can actually make this 15 different types if you use the CLI. Okay, so I've followed best practices. I'm allowing the cluster to spin up across multiple different instance types, looking at multiple availability zones. Finally, we're going to configure cluster scaling. This is where we can use that graphic that we showed around minimum units between core and task. So let's go ahead and say at any given time, we need a minimum of 8 units, which 4 of them will come from the core and 4 of them will come from the task. Let's allow it to spin up to, I don't know, let's say like 80, we'll say 84 units. That should be a total of roughly 21 instances, 21 times 4, right? The on-demand limit, I'm going to limit this to 4 units. And the reason for this is I'm going to basically say, I want no more than 4 on-demand units, and those are going to come from this 4 on-demand units that the core is contributing. This effectively restricts me to using Spot for the pure Spot for the task nodes, right? So I'm going to pin the most on-demand from a pricing perspective at 4, maximum at 4, and then maximum of 84, which means whatever's left over from these 4, 80 of the units will come from Spot.
Cool.
Cool. All right, let's click next. Let's name our cluster. We'll call this Cloud Academy. We'll turn off logging and everything we don't need here. We'll name this. Okay, finally, let's go ahead and launch our cluster. Everything else here we're going to leave alone. If you've used EMR in the past, in order to launch your cluster with using the allocation strategy, you may need to update your EMR rule. You'll get a note about that. Easiest thing to do would simply be to remove the existing roles and allow EMR to create new ones for you, just to make sure that all of your permissions are in place for the allocation strategy. All right, finally, I'm going to create cluster. I want to make sure we're good on time here and kick this off. Okay, so we've now launched a cluster, and it's going to kick into the provisioning state. I can monitor the hardware and how much capacity has been launched here, and we can see that it's moving into the provisioning state. And so what EMR is effectively doing right now is spinning up the instances that will be used to power each of these master, core, and task instance fleets within my EMR cluster. So this is going to take us a moment here. Stu, any questions?
We've got some questions that have come in just while that's spinning up. So the question here, someone's asked, can I use Spot with other big data frameworks or services outside of EMR like Cloudera?
You definitely can. And we've worked with different providers to help them with their Spot integrations as well. So there are others. Databricks, for example, and Qubole both have really good Spot integration with them as well. Cloudera, I need to regroup on that one and see exactly where they are with utilizing Spot, but you definitely can in many places, and it's a really important thing. And if there are any out there that you don't see Spot available, please let us know so we can see what we can do to help integrate.
Nice. We've got a couple more as well. What types of instances should I diversify my nodes across when using EMR?
Yep. So typically, you want to think about the instance types that provide the appropriate memory to CPU ratio for your workloads. So I think, as I mentioned earlier, with Spark, because it's a memory, in memory process, typically you probably want to use instances that have a higher ratio. So the R's and the M's, for example, have that higher CPU to memory ratio. If you're using something more like Hadoop that doesn't need to have as much in memory, you can use something like the C instance types, because they provide a lower ratio of CPU to memory, so you're going to get more bang for your buck from a CPU performance perspective. You can throw more compute at the workload without having to worry about adding as much memory at the same time. So we typically will see customers focus on the R's, the M's, and the C's, and within those, the size is just relevant to, again, what the minimum number of memory and CPU ratio you need per executor or per unit of work within the cluster. Does that help answer the question?
Yeah, I think so. So I guess it really kind of depends on your workload as well.
Yep.
I think that's still provisioning at the moment. We've got time for another question.
Yep, one more. Yep.
Can I update an instance from on-demand to Spot in a running cluster? That's an interesting question.
Yeah. So typically, when you launch, once the instance fleet has provisioned, it's going to continue to provision from the same type of instances that it started from. So if you chose on-demand for a ratio of on-demand and Spot, for example, in the core, it's going to maintain that ratio based on your scaling policy, but it won't flip between Spot and on-demand, and you can't change them in an existing cluster. once you've provisioned. At provisioning, you can actually have provisioning timeouts, and you can choose, well, if I didn't get a spot instance after a certain amount of time, I can ask for an on-demand instance instead, but that's only at provisioning and not in a running cluster.
Okay.
So if I flipped over, and if Stuart, if you have more questions, if you want to throw them at me, you're welcome to. Otherwise,
No,
I can.
let's carry on with the demonstration. A handful of other questions, but we can come to those at the Q&A session at the end.
Okay. So let me just flip over to the EC2 console. If I look in my running instances, EMR provisions in the customer's account. So we can see that the instances that are tied to my cluster here are these that have the tag of Cloud Academy. So let's filter by those. Am I spelling it wrong? Oh, sorry. There we go. So we can see that we have 2 instances spun up, and these are powering the cluster, and it chose the M4 extra large. So that means that it decided those were the most optimal to use for the cluster. Let me flip back to the EMR console here and take a look at how we're doing.
Does it show you on that instance screen there which node type it was, if it was the core or the task?
On this one, let's see if we have the tag for it. Yep, so EMR tagged it with the value of group role of core.
Cool.
So we can see that this is the core node and this is the master node. And when the task node spins up, it will be flagged accordingly. I want to make sure that I don't run out of time here. So if we haven't finished provisioning here, so it's marked master and core already, and now the task node is simply launching. Oh, so one thing I can show, let me refresh this. There's our task node that's spinning up. Here in the console, I can actually see the life cycle. We can see that the master node and the core node are both on demand, and the task node is a spot instance. We call that life cycle.
That's pretty cool.
Yeah, so we can see that it's doing what we asked it to, which is launching a spot instance for the task node.
Good to know.
Yep, so it's doing what we asked. It's spinning up here, so it'll be ready here in a second. So let's look at our job. So what we're going to do is we're going to run a simple Spark job that is going to do a word count across a common crawl data set that has been stashed in S3. So that the S3 URL is here. We're going to ask Spark to make a map splitting on lines and words here and then reducing by the words. And so we're simply saying, please give us a word count from this common crawl data set. Once you've completed your job, or as you complete the reduce here, save the output back into S3, into an S3 bucket that I've created called Cloud Academy, and I'm asking it to go into an output, make a folder called output and save the output there. So it's a very simple job, but this is a pretty big data set, and so this would take quite a while if I was just running on a single instance, for example. So I've taken this job and I've put it into my S3 bucket. And so what I can now do, let's see if we're ready to go here. Still provisioning, but let's run the job anyway. I can go to my steps section and I can say add a step. And so a step is basically a job within EMR. I'm going to select Spark application. And I'm going to say the application location. And again, I copied this into my S3 bucket called Cloud Academy, and I called it wordcount.py. So I'm going to select it. So this is how you launch a step. You simply point it at your application, which this is the exact wordcount.py Python file that I just showed you here.
Okay.
I can add this, and that's it. I've now submitted a job. And so this job is now running, is submitted into my cluster. And so EMR is going to take this job. It's going to understand, what how much capacity can it use to run this job, and it's going to look at what it has provisioned so far, and then it's going to take into account the scaling policy, and it's going to understand, well, to effectively run this job, how much capacity can I add and do I need to add to run this job. And so it's going to look at that, break it down, and then managed scaling will pick up and say, well, I need to actually add some additional capacity to my cluster to get this job done, and it's going to add additional units to my task nodes, because that's where I have allowed it to add capacity. So let's come back up here. There's also this events tab that will kind of give you a history of what has happened on the cluster so far. So let's go back to our steps. We'll refresh here. All right, so our job has actually kicked off already. We can see, let's see, let me refresh this. Oop. Okay, so we can see here that the cluster history is here, and we can see that the job has moved into a running state, and we can see that it's thinking about the fact that it needs to add additional capacity. So let's come back down here and refresh. Sorry, my scroll is a little bit funny. So we can see that managed scaling has picked up the fact that it wants to add more capacity. So it's actually resizing my task instance fleet to the total of 80 units that we allowed it to scale up to. So we gave it a maximum of 84. 4 of those are already coming from the core nodes, so the remaining 80 are now going to be coming from the task as spot instances. So if I come back to here and I refresh, in a moment here, we'll see that EMR is beginning to add, I believe, what would be roughly 20 new instances, because 20 times 4 is 80. So there we go. So we can see that EMR has now spun up these instances here. They're going to bootstrap. They will then be added to the cluster, and they will then begin to accept units of work from this job that is running here. So it's kind of neat to watch this all take place and all happen.
Yeah,
And
definitely.
Sorry,
It works. I was just agreeing with you. It's great to see how the process plays out as you run the job, and how it calls in the task nodes as the spot instances.
Cool. So just looking at the clock, I mean, I can keep my screen up here. Stu, is there any other questions, or did you want to talk through anything else here as we kind of watch this?
Yeah, I mean, we can kind of jump into some questions now that have come in. So we have a question here. Is there any performance difference when using EMR with S3 or HDFS?
There's a lot to take into consideration there. Typically, when you're using EMR FS or S3, you're basically copying the data from S3 and then storing it in memory. So depending on how much shuffle there is between the two, there can be a difference in performance. It just depends on how much read and writes are happening. EMR FS though has been highly tuned and for this particular use case. I don't want to say exact differences between the performance of the two. HDFS would be using a local storage on the instances, whether that's through instance storage or through EBS. So there's just a lot of variables there. In general, though, if your workload is read once, from S3 and compute and then put it back, you're going to have great performance. If you're doing a ton of read and writes between the two, your performance will be slightly less, just due to the fact of shuffling data around quite often.
Okay, we have another question. AWS also has an option to set up Cloudera Hadoop with the help of Cloudera Director. So how is EMR beneficial compared to Cloudera Hadoop?
Yeah, I mean, I think it's just a matter of comfort level in terms of what you've used in the past, and then as well as sort of using the native AWS services versus the partner environment. Like, I think they're both fantastic, and I think it's just a matter of understanding what have you used in the past. Maybe it's a factor of licensing or something like this, or other arrangements. EMR is tightly integrated with other AWS services, and you have built-in native permissions like IAM and things like that. And it's just really a matter of those. But I think they're both great options, and I don't want to say there's any difference between them. It's just a matter of choice from the customers.
Sure. Just looking through the questions. Will choosing the maximum instance increase the cost?
The maximum instance size is that?
I assume so. Yeah, I assume that's the maximum instance size.
Yep. So because the allocation strategy is, if you use allocation strategies, it is going to take into account the on-demand price. So it will select the most cost optimal from the on-demand side. As far as Spot goes, Spot is strictly looking at available capacity because Spot is already discounted off of the on-demand price as much as we possibly can, right? You're going to see 60 to 80% to 90% even off of the on-demand price. When it uses the capacity optimized allocation strategy, it's really looking about access to spare capacity and less about price. So if you had an instance type that was slightly more expensive than another, but we happen to have more of them in terms of spare, yeah, we would probably use the one that is slightly more expensive, understanding though that you're only ever going to pay the current spot price. So your savings are still going to be very steep over using on-demand instead.
Sure.
So I hope that answers the question.
We've got a question that's come in, probably relevant to what's going on the screen now. They've asked, would the instances auto shut down post the process when it's complete, or is it configurable for how long the cluster has to keep it up and wait for further jobs?
It will automatically shut them down after it notices that it hasn't had any work. Details for the timing of that, I believe, are in the documentation. I can't recall the exact metrics that it uses. But it's going to be attempt to be very aggressive because it scales up and scales down so quickly, then it can get more aggressive about how quickly it shuts things off and how quickly it adds capacity back. So the idea is that it's really fine-tuned to the actual depth of the queue, the job queue, versus leaving things running that aren't being utilized. So it tries to stay very true to that graph that I showed earlier in the presentation.
Sure. Okay, we've got one last question here. We saw that you can execute Spark scripts with adding steps. Is there a possibility to add steps with dependency? So when one's completed, then another step starts?
So in terms of individual steps, you submit them and they kind of go in the order that you've submitted them. You could build dependencies into this individual steps themselves, I guess. Is my answer to that. Whether you can natively build dependencies within EMR directly, I'm not completely sure what power there is there, so I don't want to say the wrong thing. But typically it's kind of first in first served kind of thing, but it also is subject to availability within the cluster. So I hope that answers the question, but I know it's not a complete answer. I just don't want to say the wrong thing.
I appreciate that. So how are we doing with the demo? Is it still running?
Yep, it's running and it's scaled up completely. We have all of the nodes provisioned. If I flip back here, you can see they're all chugging away. It looks to me like at this moment, M4 extra large is what it really latched onto from from spare capacity. So it's doing its thing, and it's chugging away. So yeah, let me look in my S3 bucket and see if I have any output yet.
It's kind of the final step, but if it's not there, then we can probably wrap up anyway.
Yep. Yeah, it hasn't written anything out yet, but yeah, it's chugging away. I mean, we can see monitoring. This will be the last thing I show. Yep, we can see that it's really scaled itself up in terms of utilization. So
excellent. Well, we haven't had any more questions, and we're kind of on the hour as well, so I'll just wrap this up. So again, thank you all for joining us today, and a special thanks to you, Chad, as well, for a great presentation and demonstration. It really helped to clarify how simple and effective it can be to use Spot instances within your cluster to run certain jobs, and to monitor how it went through that process was great. So I appreciate that. I've certainly gained some takeaways from this webinar, and I hope all the listeners have too. We've had some great questions, so it certainly shows that this is definitely a topic of interest for a lot of people. As a reminder to everyone, you'll receive a recording via email as soon as it's available. And don't forget to check out all our other webinars, which you can find on our website at cloudacademy.com. Do you have any closing remarks, Chad?
I just want to say thank you so much, Stu, for having me, and everybody at Cloud Academy. Been great,
No,
and
thank
thank
you,
you.
guys.
Yeah, and thank you everyone for attending. It's been great. I hope hope we learned something here together. And again, don't be shy. Reach out. Would love to hear your use cases. And again, just thank you so much for everybody's time.
Cheers. Thanks so much. Thanks, everyone, and goodbye.